Some stories were buried and not forgotten. Some warnings were heard, but ignored, and some truths still echo in silence. This is Pale Frequency.
Something returned from Columbia on the morning of February 1st, 2003. It came back in pieces, across a debris field stretching 500 miles, from the skies above California to the fields of Louisiana. Investigators eventually recovered 84,000 fragments. Tiles, wiring, thermal protection panels, pieces of the crew module. They found crew remains. What they did not find, what has never been recovered, is a satisfying answer to the question everyone stopped asking. NASA knew, before Columbia ever left the ground on January 16th, 2003. The information existed. The damage was observed. The emails were sent. The requests were made. And then, at each decision point, in each meeting across 16 days and 82 orbits, someone decided not to act. This is the signal that was never supposed to reach you. This is the transmission pale frequency recovered. The Space Shuttle was not designed to be safe. It was designed to be affordable. That distinction cost 14 lives. When NASA first conceived of the shuttle program in the early 1970s, the agency had ambitions that outran its budget by an enormous margin. The original design called for a fully reusable system, a winged orbiter launched atop a winged booster, both piloted back to runways after each flight. It would have been revolutionary. It was also projected to cost $12 billion to develop. Congress gave NASA $5.4 billion, so NASA compromised. The fully reusable booster became solid rocket boosters, cheap, expendable, and later implicated in the Challenger disaster. The thermal protection system, originally envisioned as metal shielding, became ceramic tiles, 24,000 of them, hand-applied to the orbiter's exterior, each one fragile enough to shatter if dropped. The external tank was covered in spray-on foam insulation. The foam kept ice from forming on the tank's surface during fueling. The foam was also prone to shedding. During ascent, past the orbiter, at speeds exceeding 2,000 kilometers per hour, NASA called this an acceptable risk. They called it that for 22 years. Columbia launched on January 16, 2003 at 10:29 in the morning, Eastern Time. The crew of STS-107 had been waiting 2 years for this flight. The mission had been bumped from the schedule 11 times. Commander Rick Husband, pilot William McCool, mission specialists Michael Anderson, Kalpana Chawla, David Brown, and Laurel Clark, payload specialist Elon Ramon, an Israeli Air Force colonel, and the first Israeli astronaut in history. 81 seconds after launch, a piece of foam insulation, approximately 44 centimeters long, approximately 30 centimeters wide, detached from the bipod ramp area of the external tank. Engineers who reviewed the launch footage that afternoon calculated its mass at approximately 750 grams. At the moment of impact, the relative velocity between the foam and Columbia's leading wing edge was approximately 840 kilometers per hour. The foam struck reinforced carbon-carbon panelate on the left wing's leading edge. In the mission control footage from that afternoon, the strike registers as a brief gray smear on the launch video. Easy to miss, easy to dismiss. Someone flagged it within hours. Someone else decided. It was probably fine. On the second day of Columbia's mission, January 17, 2003, an engineer at NASA's Johnson Space Center, named Rodney Rocha, sent an internal email. Rocha was the co-chair of the debris assessment team, a group of engineers convened specifically to evaluate foam strikes on shuttle orbiters. He had watched the launch footage carefully. He had seen the impact, and he wanted better imagery. His email requested that the Department of Defense be asked to use military spy satellites or ground-based telescopic cameras to photograph Columbia's left wing in orbit. The technology existed. The resolution was sufficient. The request was entirely reasonable. But the request was denied. Mission management determined that the foam strike, based on previous flights, posed no safety of flight issue. Rocha sent another email, and then another. Each one measured, professional, but increasingly concerned. He described the foam strike as in a class by itself, compared to previous impacts. He wrote that he was not comfortable with the assessment. He said he needed better data to reach a confident conclusion, but no imagery was requested, and no imagery was obtained. Days passed, and the uncertainty remained. On January 22nd, Rocha wrote what would later become one of the most devastating documents in NASA's institutional history. He drafted an email criticizing the decision to cancel the satellite imagery requests, calling it the height of simplistic thinking. He wrote the email, and then he stared at it for a long moment, and he did not send it. Instead, he took a screenshot of the message and quietly saved it in his personal files. Too aware of what speaking up might cost him, that screenshot remained hidden until Columbia came apart over Texas. And in the aftermath, that unsent email became a silent record of a warning that never reached the people who needed to. While Rocha's unanswered emails accumulated, Boeing was running its own analysis. Using a software program called Crater, Boeing engineers attempted to model the damage the foam impact might have caused to Columbia's wing. Crater had originally been designed to assess small debris strikes, micrometeorites, tiny chunks of ice. It had never been validated for an impact of the size and velocity of the STS-107 foam strike. But the engineers ran the analysis anyway, and the results were alarming. Crater predicted that the foam had penetrated the RCC panel entirely, that the impact had punched completely through the carbon-carbon composite material, the very material protecting Columbia's wing leading edge from re-entry temperatures exceeding 1400 degrees Celsius. This result was not presented to mission management. Instead, the engineers revised their methodology. They ran the analysis again with different assumptions. And this time, the results were less alarming. Those results were presented. The Columbia Accident Investigation Board later described this process precisely. The engineers had worked backwards from the desired conclusion. They wanted Columbia to be safe. They needed Columbia to be safe. And so, they found, through the quiet pressure of the system and the weight of expectation, the data that told them it was the person most responsible for the STS-107 foam strike assessment was Linda Ham, the lead flight director and chair of the mission evaluation room. Ham was not incompetent. She was experienced, respected, and operating within a system that had trained her to think in a particular way. That way of thinking would later be given a name by the Columbia Accident Investigation Board: normalization of deviance, a concept first described by sociologist Diane Vaughn. In her study of the Challenger disaster, it describes something dangerous, something quiet, something invisible, how organizations slowly, almost imperceptibly, begin to accept abnormal conditions as normal, not because they are safe, but because nothing has failed. Yet, the shuttle program had experienced foam strikes on nearly every previous flight. Pieces of insulation breaking away, striking the orbiter at high speed. Each time it happened. Each time, nothing catastrophic followed. And so, the conclusion became inevitable. Foam strikes were acceptable. This was the logic. That killed the Columbia crew. Ham's assessment, delivered inside the mission evaluation room on January 24th, 2003, was calm, measured, certain. Even if the foam had caused tile damage, it would not pose a safety of flight risk during re-entry. Her reasoning was built entirely on the past, on previous missions where tile damage had occurred and nothing catastrophic had happened. But this time was different. The assessment was final. There would be no further analysis, no additional imaging, no escalation. On January 25th, NASA officially closed the foam strike issue. The risk had been dismissed. The uncertainty had been buried. Columbia had 9 more days in orbit. The crew of Columbia did not know the truth. This is the fact that is hardest to sit with. Rick Husband, William McCool, Michael Anderson, Kalpana Chawla, David Brown, Laurel Clark, and Elon Ramon spent 16 days conducting scientific experiments, filming footage of Earth, speaking with their families during scheduled communication windows, eating freeze-dried food in microgravity, sleeping in their assigned bunks, doing the work they had trained years to do. They were not told about the foam strike assessment. They were not told that engineers had requested satellite imagery of their vehicle and been denied. They were not told that the Boeing crater analysis had initially predicted complete panel penetration. They were not told that their flight director had declared the issue closed. They were told nothing because mission management had decided. There was nothing actionable to tell them. Kalpana Chawla had dreamed of space since childhood in Karnal, India. She had a doctorate in aerospace engineering. She had flown once before in 1997 and had spent the intervening 6 years waiting to fly again. Elon Ramon carried with him a small pencil sketch, a drawing of Earth as seen from space, made by a 14-year-old Jewish boy named Peter Jins, who had been murdered at Auschwitz in 1944. Ramon had asked to carry it as a symbol of what humanity could become. These were the people inside the vehicle. These were the people the emails did not reach. Re-entry began at 8:44 a.m. Eastern Time. The orbiter's nose pitched up to an angle of 40 degrees, presenting the reinforced underbelly to the oncoming airstream. The thermal protection system absorbed the heat, preventing it from conducting through to the aluminum frame beneath. The left wing's leading edge was protected by reinforced carbon-carbon panels. Panel 8 was compromised. At 8:48 a.m., sensors in Columbia's left wing began to register anomalous readings. Temperature sensors in the landing gear compartment showed elevated readings. The readings were transmitted to mission control in real time, logged automatically, and initially interpreted as sensor malfunctions. At 8:53 a.m., Mission Control received the last complete communication from Columbia. The mechanical systems officer, Jeff Kling, noticed the left wing sensors going dead and flagged it to Flight Director Leroy Kane, who asked his team to verify. At 8:59 a.m. and 32 seconds, Mission Control received a fragmented transmission. Rick Husband had begun a response to a call out from the ground. The transmission cut out in the middle of the second word. It was the last signal from Columbia across the southwestern United States. Witnesses began reporting streaks of light in the sky. Not one streak, multiple. A debris field spreading across hundreds of miles. Moving northeast, people in California, Nevada, Arizona, New Mexico, Texas, Louisiana came outside and watched pieces of Columbia burn. Across the morning sky, At 9:16 a.m., Flight Director Leroy Kane formally locked the doors of Mission Control and ordered his team to preserve all data. He knew, they all knew, the 7 people who had not been told were already gone. The Columbia Accident Investigation Board, 13 members, 7 months, 2,500 interviews, produced a report that NASA called thorough and that the families of the Columbia crew called insufficient. The board's conclusions were unambiguous. The physical cause of the accident was the foam strike to RCC Panel 8. The organizational cause, the cause that made the physical cause fatal, was NASA's institutional culture. The board identified the same dysfunctions that had produced Challenger 17 years earlier: the normalization of deviance, the suppression of dissenting voices, the pressure to maintain schedule, the tendency of mission management to hear what it wanted to hear and dismiss what it did not. The board made 29 recommendations. NASA accepted them. The shuttle flew again in 2005, in 2006, in 2007. Engineers continued to flag foam strikes. Foam continued to shed from external tanks on nearly every subsequent flight. The shuttle program ended in 2011. It was only after the tragedy that the full truth came out. The possibility of survival existed. NASA engineers worked with the investigation board to map out a scenario, extraordinarily difficult, risky, perhaps impossible, in which a rescue mission could have been mounted. Atlantis was in processing. At Kennedy Space Center, a launch could theoretically have been prepared within the 16-day window, an emergency spacewalk to assess and potentially patch the wing damage was not physically impossible. None of these options were evaluated in real time. They were not evaluated because officially there was no problem. The debris field from Columbia was eventually mapped across a corridor 560 kilometers long and 80 kilometers wide. Recovery teams spent months walking that corridor. They recovered 84,000 fragments, approximately 38% of the orbiter's dry weight. They found crew remains. In East Texas, they found Elon Ramon's diary, waterlogged but legible. Rodney Rocha testified before the investigation board. He described what it felt like to know afterward that the crew had not known what he had known. He said, I failed. I failed as an engineer. I failed as a human being. The investigation board disagreed. Their report called him one of the few individuals within NASA's system who had functioned as intended, who had raised concerns, documented them, escalated them through available channels, and been denied at every step by a system that had no mechanism for hearing what it did not want to hear. The system failed. The engineers who trusted the system failed alongside it, and 7 people who were never told the truth came home in fragments across 500 miles. This transmission was always there. It was waiting for someone to receive it. You received it 16 days too late.
The signal never disappears. It just waits to be heard. Subscribe to Pale Frequency and stay tuned.